Hello, class. We're going to get started with a recording for the Math 410 Elementary Algebra for Section 6.3 area. So again, sorry for the delay at the beginning. I have trouble with the document camera reflecting correctly the pages sometimes. So I have to just kind of turn it on and off until it takes. I'm not sure what the issue is. Um, and it seems to only happen when I'm trying to record. Doesn't seem to happen during the classroom Zoom live lectures, but it just seems to happen when I'm just trying to do the recording. So to take a look at that. All right, so for section 6.3, remember that you want to do 15 minutes of learn in your Hawks Learning, and that should cover the time on these pages. So these are part of the ebook, but they're taken from the ebook, but they're in your workbook. And so I believe these like watch and work videos, these little videos, they're not in your ebook. Your ebook textbook, your ebook electronic book in Hawks Learning is another reference for you to have to see some practice problems worked in the pages. And then in your Hawks Learning Learn, the Learn, Practice, and Certify, in the Learn, when you go through the pages, that helps you go through these kind of fill in the blanks. So I have a teacher's edition, but yours are blank. So as you go through the Learn, they will walk you through that and fill those pages out. And then you'll come across little videos that you can look at. So you definitely should look at that to see what their perspective is at. So these authors, I think the gentleman's name is Franklin Wright, right? And the publishers are from South Carolina, and so I'll double check and read up on the author to see where the author is from. I don't think the author's from Texas, but I'm thinking I would guess it's probably South Carolina along those lines. But I'll double check. But it'd be good for you to get a different perspective besides how your teacher teaches in the classroom. You're going to see these videos and presentations from the people who support the actual writing of the book. And so it'll be good to get another perspective of things as well. Okay. And so I'm going to start with these problems for area. And these are the ones that the math department makes. So a lot of times in the summer, we're charged with, assign tasks and to make workbook problems and things like that. So the math department gets together and creates these extra problems for the workbooks. So this is what we put together here. So the first one says, find the area of a square with sides of length 13 inches. So they really didn't have to put 13 in two places. They really only needed it in one spot. And then, you usually put a little symbol here, and that means that all the sides are going to be 13 inches. This is a right angle, and that little figure there is measured at 90 degrees. If you remember what a protractor is, that would measure that at 90 degrees. So a protractor is a little tool, kind of looks like this. This looks like it has a ruler on one end, and it's used to measure angles, if you remember using that. So I used to use that in high school in geometry, a protractor. Okay, so what your teacher's going to want, like if this were a test problem, what your teacher's going to want is the formula, the substitutions, and then any of the arithmetic, the carrying involved, and then the units, and then you want to double check your work on the calculator at the very end. So if you look at this problem, you've got a square. So you look at your square and notice how you want to find the area, not the perimeter. Sometimes on tests, I notice that people miss that because they found, the perimeter instead of finding the area, for example. So you want to pay attention to this. Does it want you to find the area, or does it want you to find the perimeter? P at the top stands for perimeter. A at the bottom stands for area. Okay. Now this is a circle. We haven't seen any circles, or at least not not lately, you know, in these few pages. But C is, it stands for circumference, but it's also like P, you know, different distance around an object. So this is distance around a circle, and they call that C instead of P. But just pay attention to that because you want to find the area. So you want to use this. A is equal to S squared for side squared. Okay, so you write down the formula, then you do your substitutions, and the side is 13 inches and it's quantity squared. Now, what that means is that means that you're taking 13 inches times 13 inches. And 13 inches times 13 inches can be looked up on the multiplication chart. And it also can be looked up, you know, on your calculator. You can do that by hand. But if it's on the multiplication chart, I would just, you know, look that up. 13 times 13. So 13 times 13. See that right there? 13 times 13 is 169. Okay. So this is 169, and then inches times inches is going to be inches squared, because inches has a little imaginary exponent of 1, and what you want to do is you want to keep the base of 1 and you want to add the exponents, and that's how we get 169 inches squared. So when multiplying like bases, you keep the base, keep the inch, and add the exponents 1 plus 1. So area is always units squared. Remember, perimeter is just units. Area is always units squared, okay? And that's for that reason. Now, if you want to learn how to use the calculator for the squared, I can show you that also while we're at it. Let's see. See this key right here? X squared, that's the squared key. So you would turn this thing on, hit 13, and then hit this little X squared. And you see that gives you 169, okay? So let me kind of highlight that key right here. The other thing you can do if you want to do, let's see, 13 raised to the second power. Here's another way you can do this, 13. And then you see this caret key right here? Hit that caret key, the hat key, and then you raise it to the second power. That's also saying 13 raised to the second power. That will also give you 169, okay? So the other key is this. And what that does is it kind of raises it to an exponent key, okay? All right. And then number 2, they want you to find the area of a triangle. Okay, so I'm going to look for the formula for a triangle for area, which here's the triangle. Notice how the base is at the bottom here. Here's your height. And you're going to use this. Area is 1/2 times base times height. Okay, and then we're going to make this 29 the base, and we're going to make this 28 the height. Okay, and you can have a choice to work with the fraction, or you do have a choice to work with the decimal, because a half is 0.5 in the decimal. And we know that because 1 divided by 2, 1 goes inside the house. This is 1 divided by 2. 1 divided by 2. So 2 doesn't go into 1, but 2 goes into 10. So if I write this out as 10 and pull this decimal up, 2 goes into 10 5 times, and 5 times 2 is 10. 10 minus 10 is 0. So that's where I get the 1/2. The teacher gets the 1/2. 1 divided by 2 on the calculator, see, is 0.5. So they're saying that this, put this 0 here as a placeholder there, okay? So you actually have a choice to work with a half or 0.5. Because I see that when I look at these numbers, at least one of them is even, I feel comfortable working with the 1/2 because I do see have at least one even number. And so the one with the 8 and even numbers, like if you're wondering how does she know one of those is even numbers in a 0, a 2, a 4, a 6, or an 8. And so you see that ends in an 8. So this is a half times the base, which is 29 meters, times the height, and the height is 28 meters. Okay, and multiplication is commutative. That means that you want to multiply the numbers 2 at a time, and it doesn't matter the order. And so because this is an even number, okay, it ends in an 8, I feel more comfortable working with a half of 28, getting that answer, and then I'll have to work with the 29. So half of 28, 28 divided by 2, if I cut 28 in half, that I think will give me 14. So let's see, 2 goes into 2 one time, 2 times 1 is 2, 2 minus 2 is 0. Bring down the 8, and 2 goes into 8 4 times. 4 times 2 is 8. 8 minus 8 is 0. So see, half of 28 is 2. And even in the calculator, you try that. 28 divided by 2. See, it does give you 14. Okay. So now this is now 14 meters times 29 meters. Okay. And so I'm going to do that by hand. 14 times 29. Okay. So 9 times 4 is 36. Carry the 3. 9 times 1 is 9. Plus 3 is 12. I'm going to scratch this off. I'm going to leave a vacant space here, or I can X that out. Okay. You can put a 0 there too. But you're going to start multiplying with the 4 times 2. So right here, you're going to start multiplying 4 or 2 times 4, I can say, or 2 times 4, or 4 times 2 is 8. And then 2 times 1 is 2. And then you're going to add everything up. So when we add everything up, let's see, looking for my other pen. 6 and nothing is 6. 8 and 2 is 10. Carry the 1. 2, 3, 4. So it looks like it's 406. And meters times meters is going to be meters squared, for the similar reason that we talked about over here. When you're multiplying like bases, you keep the base and you add these little exponents. Okay. Now, technically, I was doing this for the practice, but really 14 times 29 can be found on this multiplication chart. So I could have also have just gone through, as long as it's on the multiplication chart, of 14 times, and we said it was 14 times 29. All the way out here. So you see that right there, see that number there, right there, we say it was 406. Okay. All right. Okay, then on the bottom, they want you to find the area of a trapezoid. Okay, so go to my formulas and look for the trapezoid, just right here. See how you have a base, then you have a here at the top is the height. Okay, and we put that in. So at the bottom here, we have B. And then according to the picture for the trapezoid, at the top, you have a C. And then right here, this is your height. So that's H. Okay, so the formula is area is equal to 1/2 times the height times, or I should say parentheses, inside parentheses B plus C. Okay, and I'll stick with the 1/2. But again, you could use a half or the decimal. So I'll go ahead and put both because you do have a choice. 0.5 times H parentheses B plus C. I feel comfortable with the half for now. The height is going to be 9. And this is feet, right? And then B plus C is going to be 28 plus 11. 28 plus 11. And this is also, all these are in feet. All these in feet. If they're not the same units, you would have to do some conversions. If they're not the same units, they will usually take the larger unit and then convert it so that it's in terms of the smaller unit. And then that you want to make sure you have the same units. Yeah, so you cannot work with different units. So these all have the same units, they're all in feet. Okay, so according to PEMDAS, please excuse my dear Aunt Sally, they would want you to do all the operations inside grouping symbols. That's what P stands for you doing operations, adding, subtracting, multiplying, dividing, but to do operations that are inside, and they call them grouping symbols. So when I add the 28 plus 11, I can show that here. 8 plus 1 is 9, 2 plus 1 is 3. So it looks like that's 39. So area is equal to 1/2 times 9 feet. And then 28 plus 11 is 39 feet. Okay. All right. Okay, so then now I'm noticing that I was hoping that an even number would creep up or pop up with with this calculation, but I see that this is 39 and this is 9, which are both odd numbers. They're not even. If they're even, remember they have to end in a 0, 2, 4, 6, or 8. So then you might feel more comfortable then because they're both odd, changing the 1/2 to 0.5. And then multiplication is commutative, so you can change it like 2 at a time in any order. So if you want to next multiply 39 times 9, you could definitely do that. You want the number with the most digits at the top. So 39 has 2 digits times 9. 9 times 9 is 81, carry the 8. 9 times 3 is 27, and then you want to add 8. 27, I'm going to use my fingers. 27, 28, 29, 30, 31, 32, 33, 34, 35. Okay, so it looks like this is 0.5 times 351, and then this is going to be feet squared. Because remember, feet times feet. Remember, you have permission to add these little exponents when you're multiplying them. Okay, and then now we're going to multiply 351 times 0.5. So I don't really need that 0 in the front. It's just being really formal. And so I'm going to just put 0.5. And so I'm going to multiply 5 times 1 is 5. 5 times 5 is 25. Carry the 2. 5 times 3 is 15. Plus 2 is 17. And then I'm going to count my decimal moves, and I only have one decimal move. 351 has a decimal, but see, it's in the back, and that doesn't count. So you look at both your factors and you count. So you just have this one decimal place. So you move this over to the left this way one time. So now you have 175.5, and then it's feet squared. Okay. Okay, so now let's take a look at the next page. And in the video, at any time, if you need, if I go too fast and you're still writing, you can always pause. You can always pause the Zoom video or the YouTube video or Zoom video. You can always pause the video and until you get caught up, and then you just replay it. Okay, so this says find the area. Okay, so it looks like I had a little interruption. And I wonder, I think my air conditioner went on. And I wonder if that's what disrupted that, but it looks like it's still recording. So I just want to make sure we're still recording. It does seem like we're recording. Okay. So hopefully that'll be okay. It just might have separated the video and I might have to upload two different videos, but that would be okay. But okay, I don't know for you, but for me, this looks backwards, like a mirror reflection. So I am gonna have to play with this again. Advance content from second camera. Oops. Okay, I don't want that look. I want the other look. So let me see. Stop the share. See. Okay, let me try and turn the document camera off. And now maybe back on again. Not sure what does that. It didn't used to always do that. I just recently started doing that. Okay, there we go, right, class? Okay, I think that's working. Oh, nope. Oh, now it's backwards again. I should have left it the way it was. I was trying to put my little box of myself on the side there. Okay. Sorry. So silly. Should work. Should work. Sorry. There we go. All right. Okay, and that's fine. I think I'm gonna leave the video off. I think if I put the video, it's going to mess it up. So I don't think you have to see that. There it goes. Okay, there I am on the side there. All right, okay. So where were we? A parallelogram is a four-sided figure with opposite sides parallel to each other. And I need the formula. So if this were a test problem, your teacher's going to want the formula for the parallelogram for the area. So this is short and sweet, base times height. Area is equal to base times height. And the base is down here at the bottom, and here's your height, okay? So this is B, and this is H, okay? And so area is equal to base times height. Okay, and then I'm gonna do my substitution. So the base is 10.75 meters. And then the height is 5.84 meters. Okay. Okay, and I'm going to show that on the side here, the multiplications. I have 10.75. So the number with the most digits should go at the top. So that has here, that's 4. And then this one has 3. 5.84. And you're multiplying them, not adding them. So always indicate what you're doing, adding, subtracting, multiplying. So always indicate that here. Okay, so we start with 5 times 4 is 20, carry the 2. 4 times 7 is 28, plus 2 is 30, carry the 3. 4 times 0 is 0, plus 3. And 4 times 1 is 4, okay? And then if you want to check that right away on your calculator, that might be a good idea. 1075 times 4 is 4300. So you can, if you want to check that right away, you can. And then I'm going to scratch these out now so that I won't overuse them. I'm also going to change my ink just to help with the visualization. And next you want to either put an X here or a 0 or leave it vacant. But now you're going to start multiplying with the 8. And you see how the 8's in the second column. So you want that product, 8 times 5 is 40. So you want that 0 written here, and then you want to carry that 4. Okay. All right. So 8 times 5 is 40. Write down the 0, carry the 4. 8 times 7 is 56. And then time plus 4. So 8 times 7 is 56. I'm going to use my fingers. 57, 58, 59, 60. Okay, so I'm going to write down the 0 and carry the 6. Okay, and then 8 times 0 is 0 plus 6. And then 8 times 1 is 8. Okay. Okay, then I'm going to change my ink. And now I need 2 X's or 2 zeros. Or you can leave 2 cells vacant. Okay. And I'm also going to do this. I'm setting up now for addition. Okay. And I'm also going to scratch these out so I don't overuse them. Okay, and then I'm ready to start with the 5. See how the 5's in the third column? See 1, 2, 3. The 5's in the third column, and that is a 5. Let me fix that. Okay, that is a 5. And so you see I'm getting ready to write that product here, this third column. 5 times 5 is 25. Carry the 2. 5 times 7 is 35, plus 2 is 37, carry the 3. 5 times 0 is 0, plus 3. And 5 times 1 is 5. Okay. All right, so now I'm going to add everything up. So if I add everything up here is 0, 0, 8. Okay, here, and I usually start with the bigger number and then I use my finger. So I start with 7 and 6. So 7, 8, 9, 10, 11, 12, 13. And then I want to add 4, 13, 14, 15, 16, 17. Carry the 1. Okay, carry the 1. Now, I'm like auditory, right? Talk to myself on test. So you'll be able to do that in the Zoom. You're going to have yourself muted. So I'll be able to see you testing, and only I, the proctor, will be seeing everybody testing during test dates. So you mute yourself, and that way you can still talk. You can still talk, and then we all won't hear you. And you can still talk if that helps, because that really helps me. Like when I'm doing my math, I talk out loud. So 8, 9, 10, 11, and then 12. Carry the 1. 5 and 1 is 6. Okay. And now if I count my decimal moves, these are called factors. These are called factors. 10.75, 5.84. Those are called factors. These are called add-ins, because see, we're adding, put a plus sign here. These we're adding. These are called add-ins, because these we're adding these numbers up. Add-ins, you're adding those numbers up, right? You're adding add-ins, you're adding those up. These are called factors. So you want to count the n values there, and you require 4 decimal moves. See, 1, 2, 3, 4 decimal moves. So you start from the back and you're going to go over 1, 2, 3, 4. So it looks like area is equal to 62.7800. And remember, meters times meters, remember, is meters squared, because you're adding, this has a little 1, this has a little 1. So you're adding those exponents, and that's how you're getting meters squared. Okay. And then it does say something about rounding. They want you to round your answer to nearest hundreds if necessary. So the way that works is, you have your ones place value, and then the decimal is the n, and then you have tenths, and then you have hundreds, which is what they want you to round to. And then you look at the neighbor to the right, and this is called thousands. Thousands place value. Okay, so tenths, hundreds, thousands place value. So they want us to round to nearest hundreds if possible. So when I look at this, the hundreds is this 8. See, 7 and 8, tenths, hundreds. You look at the number to the right. Is that 5 or more? Nope, that neighbor is 0. So it's not 5 or more. So that means the 8 remains. Don't increase it by 1. The 8 remains. And why? It's because the neighbor, which is 0, is not at least 5. So it's not 5 or more, and that's why it stays. So then this gives you 62.78, and then that's meters squared. Okay. All right. So remember, if I ever go too fast, you're still writing things down, you can always pause the video and then just pick up when you're ready. But I'm going to move on now to number 5. So here they want you to find the area of the following figure. And this figure is called a composite figure, which means that it's made up of several figures. It's made up of a rectangle, and it's made up of a triangle. Okay, so when I create the formula, I'm going to look up the formula for a rectangle. So the formula for a rectangle is length times width. Length times width. Okay, so this would be the length, this would be the width. So I have length times width. So if I do my substitutions for that, length is 13 centimeters and the width is 7.02 centimeters. And if I do my calculation on the side here, 7.02, the number with the most digits should go at the top. and then times 13. Okay, and so 3 times 2 is 6, 3 times 0 is 0, 3 times 7 is 21. Okay, when you do your second row of multiplication, you either X this out or you leave it vacant, empty, or you actually put a 0 there. So you choose. But now you're going to start with 1 times 2, which is 2. 1 times 0 is 0. 1 times 7 is 7. And then you're going to add those up. So 6 and nothing, 2 and nothing, 1 and nothing, 7 and 2 is 9. Okay. And I'm going to count my decimal moves. So in my factors, it looks like I just have 2 decimal moves because this one, 13 has a decimal in the back, but that doesn't count. It's a decimal move. Okay, so it's just 2. 1, 2. So we're looking at 91.26. Okay, and you know this thing about the round your answer to the nearest hundreds. You only round at the very bitter end to avoid round off error. So when they ask you to round like that, your final answer, you only round at the very end, the final answer at the very end, because you want to avoid round off errors. Okay, so now we got the rectangle. That would be this, you know, area. That would be this area for the rectangle. We found that area. Like if you wanted to put carpet over there, carpet over that space there, that's the area. And now you need the triangle. So the triangle is 1/2 times base times height. So you see the base is here at the bottom. Here's your height. Okay, I think in your picture it's turned over. See, in this picture it's turned over. So this is still your base and your height. So the thing is, what happens for you in your triangle is this base right here. Let me see. It's purple. Even though you don't see a number written here, you do know this number is going to be the same measurement as that, which looks like it's 7.02. And for us, this would be called the base of the triangle, because remember this triangle, this is your base. It's just turned over this way, okay? So that's your base. I'll put B right here for base, okay? All right, and so I have, oh, and instead of using 1/2, I feel comfortable using 0.5 only because I see that this is also a decimal and so is this. So instead of using 1/2, I feel comfortable working with 0.5 times B times H. So the 1/2 is the 0.5. See on the calculator, if I do 1 divided by 2, that's 0.5. Okay. Also, if I show you in the calculator here, 1 divided by 2, I can put this decimal up here, pull it up and add a 0. 2 goes into 10 5 times. 2 times 5 is 10. Remainder is 0. But there's your 0.5 there. Okay. So I've got plus, I'm going to do my substitutions, 0.5 times the base, which is 7.02 times the height. And I'm going to put right here, H for height, which is 3.86. And that measurement is centimeters. So this is all the same units. They're all centimeters. So you don't have to do any kind of conversions. They're all the same units. Okay, so now when I multiply, you can multiply in any order. It's commutative and it's just 2 at a time. So you don't want to overuse. You don't want to overuse your numbers. So if I start with 0.5 times 7.00, and I show that here. The number with the most digits goes at the top. Could set that up like that. And then 5 times 2 is 10, carry the 1. 5 times 0 is 0 plus 1. 5 times 7 is 35. And then when I count my decimal moves, this has 2, this has 1. It's a total of 3. 1, 2, 3. So then I've got, let's see, come back over here. So here I forgot to put my units for the rectangle. Centimeters times centimeters is centimeters squared plus, and now 0.5 times 7.02 looks like it's 3.51 times, and that's centimeters. And I'm going to leave it at 3.51. It's 3.510, but you don't need that 0 at the end. If it were in between the numbers, in between like 5 and 3, then you do, or between 5 and 1, then you do need it. But at the end here, we don't need it. Even if the 0 were at the front, in front of the 3, then you still wouldn't need that. So I'm going to say 3.51 centimeters times 3.86 centimeters. Okay. And they both have 3 digits, so it doesn't matter which one you put at the top. So put 3.51 times 3.86. Okay. Okay, so 6 times 1 is 6. 6 times 5 is 30. Carry the 3. 6 times 3 is 18. Plus 3 is 21. Okay, so I'm going to mark this off. I'm also going to change my ink just to help a little bit. On the second row multiplication, I do need to either X this out, put a 0, or leave it vacant. But I'm going to start now with this second column. 8 times 1. 8 times 1 is 8. 8 times 5 is 40. Carry the 4. 8 times 3 is 24. Plus 4 is 28. Okay. Now I'm going to do the third row multiplication. So I'm going to do 2 X's here. And also I'm going to draw this long line. I'm going to put a plus over here. And I need two X's or 2 zeros or 2 empty spaces, because see, this is I'm going to start with 3 here. 3 times 1, and that's 1, 2, 3. So 3 times 1 is 3. 3 times 5 is 15. Carry the 1. And I should have crossed that out before. And then 3 times 3 is 9, plus 1 is 10. Okay. Okay, now I'm going to add everything up here. 6 and nothing is 6. 8 and nothing else. 3 and 1. 8 and 2 is 10, plus 5 makes it 15. Add the 1, 2 and 3, and then 1. So now I'm going to count my decimal moves. So the first factor has 2, the second one has 2. So it looks like it's 4 decimal moves. 1, 2, 3, 4. Okay, so it looks like it's 13.5486. And let me see. Actually, I needed to write this after this 91 number here. Sorry. Okay, so I'm getting a pin out. So, okay, I need the 91.26 centimeters squared plus, and then this was 13.5486. 13.5486. centimeters times centimeters is centimeters squared. Okay, and then those are the digits now. Those are like your add-ins, those two numbers you're adding. So let me put that here. Doesn't matter which one you put first here, but you want to make sure that they're lined up correctly because you're adding them, you're subtracting them, you're adding them, but when you're adding or subtracting, you need to make sure they're lined up, the decimals, okay? All right. And then you can put a 0 here as a placeholder and a 0 there if you want as a placeholder. But when you start adding 6, 8, 6 and 4 is 10, carry 5, 6, 7, 8, 4 and 10. Wow. So it looks like that's 104. And this would be like, this would be, if you read this out loud, this would be like 8,086 10,000s. 8,086. So that's tens, hundreds, thousands, 10,000s, 10,000s. So you round this to the nearest hundred, tens, hundred. This is the digit in the hundreds place. Tens and then hundreds. And that means you look at the neighbor. Is a neighbor 5 or more? Yep, it's an 8. So you're going to add 1 to that 0. So you're going to have area as approximately, as a courtesy, rounded here, it's going to be about 104.8. That was 5 more, so you added 1 to that. So 8.1. And then the rest becomes zeros. Okay. And then centimeters squared for each. So you add them up and keep the symbol. So you have 104.81 centimeters squared. And these wavy lines mean approximately equal to. That's what those wavy lines mean, approximately equal to. Okay. Okay, I have just 2 more to show you and then we'll be done. I'll be done with this video recording. All right. Now, the 2 problems I had in mind, I was able to pick one out from the ebook. So let me show you number 9 first. But then the other one, I'll have to draw that out for you. And then I had a piece of paper because I do want to highlight just number 9. And I wanted to cover the others. I'm not sure what I did with it, but I had a piece of paper to cover, but I'll just use this. Okay, so let me cover up the instructions. So for number 9, they want you to calculate the area of each figure. And in this case, it is shaded, highlighted in gray, but it just looks really light on my cover. I don't know how yours looks, but you are trying to find that area there. So you want to start off with taking the larger area. So I'm going to say area is equal to, excuse me, larger area, take away smaller area. And so we're talking about, I should say larger rectangle, right? It'd be better. Larger rectangle, the area of the larger rectangle minus the area of the smaller rectangle. So I should use rectangle. And then if I look up the area for a rectangle, You might have that memorized already. The area for a rectangle is L times W, length times width. So L times W, take away L times W. Yeah, so you're gonna have to subtract here. You're gonna take the larger area and then you're gonna subtract out the smaller area of that rectangle, okay? So the larger area, this right here, class, this right here is your larger rectangle. So that when that comes in your measurement for 6 is your length, 10 is your width there for that rectangle. So length is 6 and width is 10. Excuse me. And 6 times 10 is 60 and it's centimeters squared. Okay, then you're going to subtract the other area of the rectangle. So let me draw this silhouette here. Excuse me. Okay, and then you're gonna subtract. Now you're gonna subtract the smaller rectangle. So the smaller rectangle is this right here. That's smaller. So the length would be this 8. Put L there, and then the width is going to be that 3. There's your length, excuse me. There's your length, excuse me. And now there's your width is 3 centimeters. And 8 times 3 is 24 centimeters squared. And so now you're trying to calculate, you're trying to subtract that. So I show you that on the side here. Let's see, I have 60 and I'm taking away 24. So make this into a 10, decrease the 6, make it into a 5. And I'm gonna have to borrow, right? And have to borrow. So, because at first you had 0, you can't have 0 take away 4, so you have to borrow. And but the 6, when you borrow, it decreases it to a 5, and you carry that 1 over for this. But this is going to be, let's see, 0 to 10. 0 becomes a 10, so you have 10 minus 4. 10 minus 4 is 6, and 5 minus 2 is 3. So we're at 36 centimeters squared. Okay, so you have this larger area of the rectangle, excuse me, minus this smaller area of the rectangle, excuse me, which is what's inside here. And the larger minus the smaller will give you this leftover piece right here, scenario, this piece right there. Okay. Excuse me. Okay, so I have one more sheet to show you. And this is going to require some drawing. Let me show you what my goal is to draw something like this this figure. It's going to take a little time. Excuse me. Okay, so let's do this. It already has, this is page 13. So this is section 6.3. Yeah, that'd be fine. So it is 6.3. Okay. Okay, so let's call this example. And let's write this at the top that we're finding the area the polygons. Excuse me. Which is made of 3 rectangles. Okay, so let's draw this together. So let's see. I'm going to start. Most of the sides and the dimensions are given directly or indirectly, except there's one side where it's missing. And so let's take a look and see. So let's do this. So this is 2 meters. Okay, then let's do this. Let's call that 7 meters. Okay, then let's do this. Okay, go ahead and call that 5 meters. Okay, this one's 8 meters. Let's go back and do this. This is 7 meters. Excuse me. Okay, this one on purpose, I'm going to leave it vacant. No marking on this for now. Let's go back all the way back. It's about that same length. Okay, and then down here, this is going to be 9 of this. And then we're going to go up to the top here. And this, I guess I could use my ruler. It's kind of a long distance there to go to the top. Excuse me. It's 12 meters. Okay. So the only reason why I did this was because in your practice and in your certified, I remember seeing a problem similar to that, and I didn't really see hardly any examples in the book, except as close as something like this, where you subtract the areas. But I wanted to go ahead and do another one, so that's why we're doing this problem. Yeah. Okay, now I'm going to use my pencil because let's see, you can draw this up a couple of ways. When we're trying to find the area of this figure, this polygon, it's made up of several rectangles. And one way to describe it is if you were to draw this measurement, for example, this would be one rectangle. And then let's see, this would be, I did that on the other class like this. I've done that in the past. And that is 3 rectangles. 1 right here, 1, 2 right here, 3. And you are able to find any missing sides by, like, for example, using subtraction, following like the idea of parallel lines. So that's one way to write it up. But another way to write it up, and that's what I'm going to show you if you don't mind, the other one you can do for practice, but the other way you can write it up when you find the area of a polygon is right here. You can extend this line here. And this is called R1, rectangle 1. And then you can also extend this line here. That's called R2. Okay, I'm gonna put large lines on there. And then this is called R3. And you want to find the area of that. Okay, it's a third rectangle. So when you write that up, area is equal to rectangle 1, which is R1, plus rectangle 2, which is R2, plus rectangle 3 right here. Okay. Okay, now you know that the formula for a rectangle, that all formulas are going to be length times width. Okay, so length times width. Okay, so when we look at the first rectangle, this one, R1, you want the length and the width. So it looks like the length is going to be right here, this measurement of 5 right here. It represents that width, 5. So there's your length, and then your width, this looks like this is going to be your width for that personalized segment of this side here. This is going to be your width. So this is going to be 5 meters for length times 2 meters, and 5 times 2 is going to be a total of 10 meters squared, because m you're multiplying like bases, you keep the base and you add the exponents. Okay, now the rectangle, look at rectangle 2, that would be this rectangle 2 is right here. Okay, so if I need also a length times a width. So my length looks like I can use this right here as my length. There's 7. Don't use a 9 because the 9 comes extra information all the way out here. This is my length. And then this looks like my width right here. Okay, so my length is 7 meters. And then my width for rectangle 2 is this number here, which was the let's see, we can get that one. Let's see. If I look at all the parallel lines, see these lines? Okay. If I look at all those lines, I can make use of the longest line associated with that, runs the same parallel length to that. And that would be a total of looks like 5. Let's see. 2. Actually 12. Did I say 5? It says 12 right here. So this measurement right here, it's going to be 12. Take away. And you want to take away. So this whole measurement is 12. And you want to take away, chip away at this. You want to take away 2. But you also want to chip away at this. You also want to take away 8. Okay, so you have this entire 12, and then you're taking away this 2, shaving that off, taking that away 2, and then you're shaving this off, taking away 8, and then you're taking this so you have 12, take away 2, take away 8, and actually then you're done with that. So 12 take away 2 is 10, and 10 take away 8 is 2. Okay, so you're doing 12 take away 2, which is here. Then you're taking away 8, which is here. That leaves you with that left over. Okay, so I've got 7 meters times 2 meters, which is 14 meters squared. And then the last segment is the rectangle here, rectangle 3. That's this big rectangle here. So let's see if we have anything. It's length. We're looking for length times width. Let's see if we've got anything. So it looks like we can use, see this? We can use that for length for the third triangle. And then the width, we want a width, so we want to use the idea of subtraction. So see, we have a couple things we can do. Up here, we look at the focus on the top here. This is going to be, the whole length is 7. And then we want to take away this 5. And so you're making this shorter. So you're doing 7, take away 5. 7, take away 5. 7 take away 5, I believe, is 2. So that gives us that measurement here. And then also, if you want to find 2 another way down here at this side, if you're looking for this measurement here, you could say that you have 9 and you're taking away this 7. 9 take away 7 is 2. So you've got 2 meters. So you're able to get 2 a couple of different ways, okay? And so it's a check, okay? So 12 times 2 is 24. M times M is meters squared. So 12 times 12, and then just meters for that. Okay, so you're adding 10 meters squared, and you're adding 14 meters squared, and you're adding 24 meters squared. So remember to always show, the adding or subtracting or multiplying. What are you doing here? Okay, so add these up. 4 and 4 is 8, 2, 3, 4. So it looks like it's going to give us 48 meters squared. Okay. So this section, what I usually remember from past section, this is a section where students might have to do it twice, like in their certify and in their strikes. At each problem, you have 3 attempts. And if you miss it, it will say, okay, you missed this problem. Do you want another attempt at it, or do you want to accept your strike? So you should always say, I want another attempt at it, and try another problem like it. But then you should pause, save your work and pause, and maybe jump in with a math world tutor. Maybe they're open, I think, from 7 a.m. to 7 p.m., I believe. And you also have your Brain Fuse online tutoring league. They're open like 24/7. But you want to have a little bit of dialogue and say, look, I just worked this problem and I really thought I got it right. And you can also, pause, and then maybe you can look at your work yourself and say, okay, I really think I got this right. Did I just make a little human error? Did I just add wrong? Did I just subtract wrong? Did I multiply wrong? So you look over your work, see if you can find the mistake. But if you still really sincerely think you really got it right, like you're thinking you don't see the mistake, then you should join a Zoom with somebody in Math Row if they're still open. If it's before 7 o'clock, Monday through Thursday, they're open Monday through Thursday. Or use Brain Fuse online tutoring. They're open every day of the week, 24/7, 24 hours, 7 days a week. And then just have a little conversation with them. Like, look, you saw in the classroom, if you were there earlier today, that they do say that they know how to share screens. They can share a screen with you, and you can share their screen. So you can get that dialogue going. But then reattempt that problem so that you don't have to get a strike. You have 3 attempts at the problem. So what I remember about this section is that usually this is a section where students have to go back to the drawing board, go back and, to the practice or try to certify again. And so show your work like this so you can practice that write down the formula, substitution, show your work, and then check it on the calculator, okay? And if you're trying to find errors, let me see if I can go back and look at something. I think I've done this in class too. If you want to demonstrate a check. Yeah, like if you want to, like, if you find a mistake and you want to check it on the calculator, like let's say this 7.02 times 13, and we said it was 91.26. Let's say, like, if you were to get it wrong, once you do 7.02 times 13, and it's supposed to be 91.26, and we got that. But if there's an error here, what you can do is you can do 702 times 3. So 702 times 3 is 2106. See? So you can do it step by step, and I leave out the decimal. So 702 times 3 is 2106. And then you do 702 times 1. And that gives you back itself 702. See? But then you have to remember that you have to leave a gap here, remember? That's because you're doing this second row of multiplication. Okay, so if there's an error here or here, you can kind of check that way. But then otherwise, you just, you add and you just kind of double check with that. Okay. All right. So those are my notes for this section 6.3. Okay. And so good luck with that on your homework then. Okay. Take care.